The Gravity and Orbit Simulation is an interactive educational tool designed to help students understand the fundamental principles of gravitational forces and orbital mechanics. This simulation allows students to investigate how the positions of the Sun, Earth, Moon, and a space station affect their gravitational forces and orbital paths. By providing a visual and hands-on approach, the simulation enhances students' understanding of how gravity controls the motion of our solar system at a real-world scale. The Gravity and Orbit Simulation focuses on the principles of gravitational forces and orbital mechanics, which are crucial in understanding the behavior of celestial bodies. It illustrates how the gravitational attraction between bodies determines their orbital paths and the overall dynamics of the solar system. The simulation includes various tools and visual aids to help students explore these concepts in depth. The simulation features the Sun, Earth, Moon, and a space station as the primary celestial bodies. Students can move these bodies to observe how their positions affect the gravitational forces and orbital paths. The simulation allows students to observe the gravitational forces between the celestial bodies. Gravitational force is the attractive force that exists between any two masses. The strength of this force is proportional to the product of the masses and inversely proportional to the square of the distance between them, as described by Newton's law of universal gravitation. The simulation displays the orbital paths of the celestial bodies. These paths are determined by the balance between the gravitational forces and the centrifugal forces acting on the bodies. Students can observe how the orbital paths change as they move the celestial bodies. The simulation allows students to adjust the positions of the Sun, Earth, Moon, and space station. By moving these bodies, students can observe the resulting changes in the gravitational forces and orbital paths. The simulation explores the motion of the solar system at a real-world scale, providing students with a realistic representation of the gravitational forces and orbital mechanics in our solar system. The Gravity and Orbit Simulation provides a hands-on approach to exploring the principles of gravitational forces and orbital mechanics. By moving the Sun, Earth, Moon, and space station, and observing the resulting changes in the gravitational forces and orbital paths, students can understand the following key concepts. The gravitational force between two bodies is determined by their masses and the distance between them. Students can observe how the gravitational force changes as they move the celestial bodies closer or farther apart. The orbital path of a celestial body is determined by the balance between the gravitational force and the centrifugal force. Students can observe how the orbital paths change as they adjust the positions of the celestial bodies. The simulation provides a realistic representation of the gravitational forces and orbital mechanics in our solar system. Students can observe how the positions of the Sun, Earth, Moon, and space station affect the overall dynamics of the solar system. The simulation allows students to explore the orbit of a space station around the Earth. They can observe how the gravitational forces from the Earth and the Moon affect the orbital path of the space station. The Gravity and Orbit Simulation offers several educational benefits. The simulation provides an interactive and engaging way to learn about the principles of gravitational forces and orbital mechanics. Students can actively participate in the learning process by moving the celestial bodies and observing the resulting changes in the gravitational forces and orbital paths. Gravitational forces and orbital mechanics can be abstract and difficult to understand. The simulation provides a visual and tangible representation of these concepts, making them more accessible and understandable. Students can experiment with different positions of the celestial bodies and observe the resulting changes in the gravitational forces and orbital paths. This exploratory approach encourages critical thinking and problem-solving skills. The simulation provides a practical application of the principles of gravitational forces and orbital mechanics, which are fundamental to many real-world phenomena, such as the behavior of celestial bodies, the design of space missions, and the study of the solar system. This helps students see the relevance of these concepts in everyday life. The simulation introduces students to the process of data collection and analysis. By observing the gravitational forces and orbital paths, students can collect data and analyze the relationship between the positions of the celestial bodies and the resulting forces and paths. To implement the gravity and orbit simulation in the classroom, teachers can follow these steps. Begin with a brief introduction to the concepts of gravitational forces, orbital mechanics, and Kepler's laws of planetary motion. Provide examples to illustrate these concepts and explain how the simulation will help students understand them. Demonstrate the simulation to the class, showing how to move the Sun, Earth, Moon, and space station, and observe the changes in the gravitational forces and orbital paths. Explain the importance of observing these changes and how they relate to the principles of gravitational forces and orbital mechanics. Allow students to explore the simulation in small groups or individually. Encourage them to experiment with different positions of the celestial bodies and observe the resulting changes in the gravitational forces and orbital paths. Provide worksheets or prompts to guide their exploration and data collection. After collecting data, have students analyze the relationship between the positions of the celestial bodies and the resulting gravitational forces and orbital paths. They can use the principles of gravitational forces and orbital mechanics to interpret the data and draw conclusions. The gravity and orbit simulation is a valuable educational tool that brings the principles of gravitational forces and orbital mechanics to life through an interactive and engaging context. By allowing students to investigate how the positions of the Sun, Earth, Moon, and space station affect their gravitational forces and orbital paths, the simulation provides a hands-on learning experience that enhances understanding of these fundamental concepts. This interactive approach not only makes learning more enjoyable, but also fosters critical thinking, problem-solving skills, and a deeper appreciation for the relevance of gravitational forces and orbital mechanics in the real world.